In this unit, we have talked about measures of center, and there's actually three measures of center. There is median and mean, which is the title of this video. There's also mode. And so, although measures of center all look at sort of the central data or looking at sort of what is typical, they do serve different purposes. And sometimes we get the question of, is median better or is mean better to use? Well, that's kind of a debatable question, but we're going to look at that in this video. And we're going to look at it through the context of number of homework slips. So let's pretend that we went around and we asked students, how many homework slips have you had this school year? And let's pretend that this is the data that we get. Now that we have our data, we could represent this in an organized way, one of two ways, or actually two different ways. We could do it in a frequency table. I'm not going to do that right now, but the other way we could do it visually is to do a dot plot. And even though we're really talking about median versus mean today, I'm going to take this opportunity to model a dot plot. Now remember, a dot plot is very similar to a line plot. It's almost silly that there's two different ones. We're really just making our axis again. On that axis, we want to know what things represent. In this case, this would be the number of homework slips. Remember, the frequency is going to be represented by dots this time rather than X's. And so when I look at my data, I see a lot of 2s, 1s, 0s, and then I see this crazy 20 in there. So when I go ahead to label my axis with my scale, I'm going to go by, normally I would want to go by 1s, but I'd have to get 1 through 20 in there. So I think I'm going to go by 2s this time, just to avoid writing a lot of numbers on there. But I have to make sure that I get all the way up to 20 since there is a 20 data value. Okay, and so this is, like I said, and you would also have a nice title in there. So let's say that this is going to be my title, and I'm just going to indicate that that would go at the top. But for right now, I'm just going to model how to do my dot plot. And it really is, it's just like a line plot. Instead of X's, I'm going to use dots. So I see I have one data value at 2. I have one at 1. Try to make them somewhat the same size. I have one at 0. Oops, mine are getting a little weird here. I have another at 0. I have another 1, another 1, I have a 20, I have 2 more coming up with 2, another person said 1, 2 more said 0, and 1 more person said 2. So this is kind of interesting because what we're seeing is we're seeing a very large cluster right here. That what I'm noticing is that it's probably very typical to have 0 through 2. In fact, this is a multimode data value set because 0, 1, and 2 all came up the identical amount of times. And then I noticed that there's a very large gap between this section, my cluster, and this 20. And remember, this thing would be called my outlier. So even though I'm not talking about median or mean yet, what I am doing is I am sort of looking at the shape of my data. And so right now I'm already saying, you know what, it's pretty typical. Kids tend to get between 0 and 2 homework slips, but there's this outlier of 2. So this is going to bring us into median versus mean. So remember, when I'm dealing with median, and I think I'm just going to split my paper down here. When I'm dealing with median, you have to make sure you order your data. What I like about the fact that it's already in a dot plot is it's kind of already ordered for me. So I have 4 zeros, I have 4 1s, and I have 4 2s. And then I have to follow it up with that 20, which is my outlier. And I look at how many pieces of data I have, and I actually have a total of 13. When you have an odd number, remember, that's kind of nice because it literally is that middle value. So I can go in 6 data values from either side, and if I find the 7th data value, that would be the middle. So I've got 1, 2, 3, 4, 5, 6, 7, and I'm noticing 1 is my median. So I think that my median is 1, which is one way to say what's typical. Now remember, mode is another way, and since it's multimodal, it could be 0, 1, or 2. So now I go ahead and I'm going to work with my mean on the other side. Mean, remember, is really another word for average, and this tends to be what we use in schools a lot. When we're doing our data for your grades, we look at averages. And let's just see what happens here. So in this case, I've got all my data, and I would really have to add up all these numbers that we see on the left-hand side. I'm not going to rewrite that, but if I add them all up, I have 4 1s, which is a total of 4. I have 4 2s, which is a total of 8, and then I have that 20. So I have a total sum of 32, But remember, I'm going to divide by the number of values, and in this case, it's 13. So if I do 32 divided by 13, I get an average of 2.46, and it's actually an irrational number, an Energizer bunny. Now, if you look at this, the mean is much higher. I shouldn't say much. It's not really that much higher, but it's higher than my cluster. My cluster ranges from 0 to 2, but yet I have an average that's over 2. My median is 1, my mode is 0, 1, or 2. So when I look at the mean, it's not that much different. But again, the reason that it's higher is because of that outlier. That outlier, which is a high number, in this case probably a negative high number, we don't really want to have a high number in this case, is making my average overall higher. So what we're noticing here is that when you have an outlier, it will change your overall average. So one thing that sometimes that we do is we'll look at, well, what would happen if we hadn't had that outlier in there? So for example, if I took that 32, which was my sum, and I got rid of the 20, and that would give me a new sum of 12. And now I divide by 12 scores instead of the 13th, because it's almost like pretending, what if that outlier never existed? If that happened, I get 12 divided by 12, which is 1. So you can see now how that mean changes. Again, is it a huge change? Not really, but it is a change nonetheless. Instead of 2.46 now, we're saying it's about 1, and that's more in line with our median. They're more similar now because, again, of that outlier. So we always have the question of, well, is median better or is mean better? Well, in some cases, you're going to find out that they may be very similar, especially even with mode. You might find that your mean, median, and mode, because they're all measures of center, are all giving you a similar typical number. However, when you are dealing with mean, you are looking at every data value counts. It's major. And that's why sometimes when you look at your scores, if you have that one bad score, you're like, oh no, that destroyed my average. It can really affect you. And so the question of median versus mean, well, that's a debatable question, and everybody can have their own opinion. But my opinion is median is a little bit more consistent, okay? Let's look, I'm coming back over here to this side now, where I was on median. Pretend again, if we did take out that 20, if I took that 20 out, pretended it never existed, and now I was only dealing with these data values for median. Now I have 12 of them instead of 13. So if I was finding it, I have to go between the 6th and the 7th, and that would actually be right here if you can see my arrow. And if you notice, my median was still be 1. So it's kind of showing you that median is a little bit more resistant. It can have an outlier in there or not have it in there, and it doesn't change as much as when you have the mean really change drastically between 2.46 and 1. Okay? So it's really a decision you'll have to make, but median tends to be more resistant and mean is less resistant, meaning it's more affected by new data values. All right? So hopefully that helps you make your decision of which one you think is better.